Hello everybody. In this video we are going to discuss about the banker's algorithm. The banker's algorithm is a resource allocation and deadlock avoidance algorithm. And we are going to use this kind of banker's algorithm when we wanted to go for resource allocation system with the multiple instances of each resource type. So overall we can say that this kind of algorithm will work on the basic policies of the bank. Like the bank is ensuring that the allocation of the available cash to the customers should be in such a way that it is satisfying the needs of all its customers. Okay, so this is the basic idea of using this banker's algorithm in the operating system. So when we talk about this banker's algorithm, we are determining whether the allocation of the resources is putting the system in the safe state. If the system is in the safe state, then the resources are allocated. Otherwise, we are going to simply reject the allocation. Fine. So there are certain things which we should keep in mind whenever we are using the banker's algorithm. Like the first thing what we should keep in mind is the data structures for the banker's algorithm. When we talk about the data structures of the banker's algorithm, here we are basically focusing on the different things what we are going to utilize throughout the algorithm. Like we are going to use the available, max, allocation and need. Okay, so here please do remember there are, when I am using n, it is the number of process and m is the number of resources. As far as the data structure called available is concerned, it is a vector of length m. M means it is indicating the number of resources. So available is the vector of length m, which is defining the number of available resource of each type. So basically it is going to talk about the total number of resources available. Okay, next comes maximum. It is going to define the maximum requirement of each process. Okay, so whatever the requirement of process is there, it can be defined by using max. Then comes allocation. Allocation is defining the number of resources of each type which has been allocated to each process. And lastly, the need. Need is a matrix which is indicating the remaining resources required by each process. Okay, so as far as the details are concerned regarding this type of data structure, it is there in the description box. You can check out that one. The next thing what we want when we are using the banker's algorithm is safety algorithm. Okay, so this algorithm is basically used to check whether the system is in safe state or no. As I have already told you, all the description regarding the data structure, the safety algorithm and resource request algorithm is given in the description box. You can go through that one. Okay, fine. So the third algorithm what we are going to see is resource request algorithm. Basically, it is going to determine whether the request for the resources can be safely granted or not. So these are the things what we are going to keep in mind whenever we talk about the banker's algorithm. Is that clear? Okay, fine. So let us understand this one more precisely with the help of example. So here I am considering a system where I am having three processes P1, P2 and P3, and we are having four resources R1, R2, R3 and R4, and in these four resources we are having multiple instances also. Like resource R1 has 6 instances. Okay, then resource R2 is having 4 instances, R3 is having 7 instances and R4 is having 6 instances. Now what exactly you mean by instance? Instance is nothing but it is the availability, the quantity of resource 1. Like for example, if I am considering R1 as a resource printer. So I may be having 6 printers available. Is that clear? So that is nothing but the instance. Hope you understood what exactly you mean by instance. Okay, so so when we are having this kind of problem and we need to solve it, or we need to illustrate it by using the banker's algorithm, let us see that one. So according to the given system, what we have considered, the initial state will be something like this. So before showing you the given requirement or given processes in the form of matrix, please do remember the initial state we are going to chalk out, or we are going to write simply by using the formula need is equals to maximum minus allocation. You people have to remember this one, right? So let us see the system what we have considered in the form of matrix. So let us talk about first the resources. As I have already told you, there are 4 resources, R1, R2, R3 and R4. And we are having many different instances. So according to the question, like here you can see, we are having the 6 instance of R1, 4 instance of R2, 7 instance of R3 and 6 instance of R4. The same thing I am writing here. Okay. So as you can see, there are 4 resources, R1, R2, R3 and R4. These are the instances. That means there are totally 6 R1 resources are available, 4 resources of R2, 7 resources of R3 and 6 resources of R4. Okay. Then the next thing what we have to see is the allocation. So initially please consider, here I am imagining that as we know that there are 3 processes and each process is having its own use of resources or its own allocation table. Okay, so P1 is holding one instance of R1, 2 instance of R2, 2 instance of R3 and 1 instance of R4. So overall P1 is having these resources or using all the resources R1 to R4 and their instances. Similarly, if you see P2 got the allocation like it is using 1 instance of R1. It is not at all using resource R2. R3 and R4 each is 3 instances. Fine. And P3, the process P3 is using 1 resource of each R1, R2 and R3, whereas it is not using any kind of R4 resource. Okay. So after allocation, let us see what is the maximum capacity of using these resources for each process. As you can see, P1 can use only 3 instance of R1, 3 instance of R2, 2 instance of R3 and 2 instance of R4. Similarly, P2 can maximum use 1 instance of R1, 2 instance of R2, 3 instance of R3 and 4 instance of R4. Finally, let us see the maximum capacity of P3 also. So P3 can use maximum 1 instance of R1, 1 instance of R2, 5 instance of R3 and it is not going to use any kind of resource R4. Okay, so now let us find the need. So this is the allocation and this is the need. So how exactly we are going to find the need? Just now you have checked with the formula how to find the need. Need is nothing but allocation, that is maximum minus allocation, right? So here you can see need is nothing but maximum minus allocation. So by checking with these 2 tables or 2 matrix, you can find out the need. I'll show you how. So let us work for P1. What exactly is the need of P1? Just check out. Maximum is 3, allocated is 1. 3 minus 1 is 2. Okay. Similarly, R2 is 3 and allocated is 2. So 3 minus 2 is 1. That means 1 instance of R2 is needed. Okay. R3 maximum P1 can use 2 instance of R3 and already it has been allocated. Okay. So there is no need. Fine. Similarly for R4, maximum capacity is 2 and 1 is allocated, so remaining is 1. Similarly, you can calculate the need of P2 and P3. Okay, I hope you people understood how I am getting it. These values I am getting simply by subtracting maximum minus allocation. Okay, like 1 minus 1 is 0, 2 minus 0 is 2, 3 minus 3 is 0, 4 minus 3 is 1. Okay, similarly we are calculating for P3 also. After the needs, after the allocation, okay, check out what is availability. Okay, so R1, the availability of R1 instance is 3. How did we get this 3? Total there are 6 instances of R1, right? And we are going to use here, check out what is the need. The availability can be calculated by simply just check with the allocation of R1. So we have allocated totally 3 instances of R1 to the process P1, P2, P3. Total were 6 instances. So 6 minus 3 is 3. So already 3 has been allocated to different processes. So we are having only 3 instances of R1 remaining. Similarly, calculate R2. The total instance of R2 allocated were 2 plus 1, 3. So 4 minus 3, we are getting 1. Okay. Similarly, if you check the total resources for R3 instances, it is 7. And allocated is 6. So 7 minus 6 is 1. Okay. Now you go for R4. R4 total is 6 and we are having allocated 4 instances of the resource R4 among the different processes. So 6 minus 4 is 2. Okay. So now let us see how exactly we are going to work on this one. So as per the assumption or consideration, P1 is going to request for the resources. Okay, how much resources of each, how many instances of all the resources P1 is asking for? It is asking for 2 instances of R1, which is yes available. 1 instance of R2, yes we can give it. There is no requirement of R3, so we are not going to check with this one. And 1 instance of R4, which can be easily given because 2 instances of R4 are available. Okay, so after allocating the need of P1, okay, the availability will get reduced. Okay, what is why it is, how exactly it is getting reduced? 2 is required, there are totally 3, so 3 minus 2 is 1. Fine. So 1 was required, available was only 1 about the resource R2. So 0 is remaining. Okay. So R3 was not required. So the R3 1 instance is already there. Okay. Now check with R4. R4 total availability were 2. P1 requires only 1 instance. So we are having availability of 1 after allocating the resources for P1. Now once the resources got allocated to process P1, it is going to complete its execution and it will terminate and returns its resources. Now when it is returning its resources, what happens? The availability will increase. What will be the availability now? After allocation, this was the availability, and when process P1 is releasing all its resources, so maximum it held all these instances. So 3 plus 1 it will be 4, 3 plus 0 it will be 3, 2 plus 1 it will be 4, and R4 is 2, 2 plus 1 will be 3. So totally 4, 3, 3 and 3. Okay. So here I have written that one. Okay. I hope you understood this one. How did I do that? Okay. Similarly, you check for P2. P2 is requesting to acquire the resources 0 instance of R1, 2 instance of R2, 0 instance of R3 and 1 instance of R4. Okay, so after getting the resources, P2 is going to complete its process and it is terminating and releasing all its resources. Okay, so what happens? Already here I am giving you the total available resources. How did we get this one? Let us have a look. So let me change here. I'll show you here only. So after P1 has released all its resources, the availability got increased and it was this one. Sorry, I'll make it here. 4, 3, this was also 3 and 3. Okay, and the process P2 required 0 instance of R1, 2 instance of R2, 0 instance of R3 and 1 instance of R4. The availability was there. So P2 is getting the resources it requested for. So after allocating the needed resources for P2, our availability vector is going to get reduced. So our P2 doesn't require R1, so 4 is intact. That means 4 instances of R1 are available. P2 requires 2 instances of R2. Total available were 3. Now 3 minus 2, we are having availability of 1 instance of R2. Okay, P2 doesn't require any instance of R3. So R3 will be intact. It will be holding 3 instances of R3. Now coming to R4, total available were 3. P2 required 1 instance of R4. So it is remaining with 2. Okay, got. So this was the availability. Now after P2 was finishing with its process, it is going to release all its resources. Okay, so what was the maximum resources it held? This is the maximum. You please do check with the maximum matrix. Okay, so 4 plus, it is going to release all these instances of all the resources P, R1, R2, R3 and R4. So available was 4 here. P2 is going to release 1 instance of R1, so 4 will turn to 5. Okay, P2 is going to release 2 instances of R2. Available was 1. 2 plus 1, it has increased to 3. Okay, so the availability of R3 instances were 3 and P2 is going to release 3 more instances of R3. So we are getting totally 6 instances of R3 available. Okay, finally please do check out with the availability of R4. After allocating the resource to P2, our availability was 2 instances of R4. And now when P2 has finished with its execution, it is going to release all the 4 instances of R4. So 4 plus 2, we are having 6 instances of R4 available. Okay, so this is what I have, 1 minute. Yeah, this is what I have written here. Once P2 has acquired the resources and it has terminated, releasing all its resources, we are remaining with the availability of 5 instances of R1, 3 instances of R2, 6 instances of R3 and 6 instances of R4. Now let us see the P3 request. Now P3 is requesting for the only 4 instances of R3. Okay, so now if you see the previous slide here, this is the availability which is there after P2 has finished with its processing and P3 is requesting for the resources. Now P3 requires only R3 resource, that to 4 instances, and availability of R3 is 6. So it is just going to allocate that one, and when P3 finished with its execution, it is going to release all its resources. Okay, so what are the resources it is going to release? This thing, the maximum matrix, you have to see. Okay, please don't get confused. Whenever you are updating your availability after processing the job or the process, you have to check with the maximum. That means these are the total number of instances what the process is going to release. Okay, so the availability was 5 3 and 1 minute, I'll just make you understand here. Yeah, 5366, right? I'll go to this previous slide. So when we are allocating the resource to P3, okay, the availability was this one before allocation. Okay, now when I have allocated 4 instances of R3 to P3, our requirement changed. It was this one, because this will be 5326, because it doesn't require any instance of R1, R2 and R4. So 5, 3 and 6 I have written intact, and the requirement of R3 was 4. Total available were 6. So we are remaining with 2 instances. Okay, so after the allocation of resource to process P3, it is going to execute and terminate, and finally it will release all the resources held by P3. Now to check what are the total number of resources held by P3, you can easily find with the help of this max matrix, this table. Okay, so P3 was holding these many resources after allocation. Fine. So what happens? It is going to release it. So what we are going to remain with? 5, and P3 is going to release 1 instance of R1. So 5 plus 1, we are going to have 6 instances of R1 available. Okay, then there were already availability was 3 instances of R2. When P3 finished with its execution, it is going to release 1 instance of R2. So 3 plus 1, 4. Okay, similarly, P3 is going to release 5 instances of R3. So this 5 plus 2 is going to become 7. Finally, P3 has not at all used the resource R4. So the availability was 6. So it will be intact. Okay, so like this, by using the resources available, what we have done is we have allocated the required resources to all the process without any problem. So we can say that the entire system was in safe state. Okay, I hope you, why we are saying this, the entire system was in the safe state, it is because all the processes were able to terminate. When we are saying they were able to terminate, that means they got the resources what they needed, they finished with their execution, and they have released the resources. Okay, so this is what the total resources were available, and these resources, this is the thing you can compare with here only. Okay, so like this you can check out how exactly the banker's algorithm work. Okay, I hope you people have understood this one. Now let us see one more example for the banker's algorithm. As in the previous example, we have seen that all the processes P1, P2 and P3 were able to complete its processing and they were able to terminate, and that state was safe state. Now here I am going to make slight changes which will lead to the unsafe state. Now the main intention of showing the same, the same type of algorithm where with the slight changes is to only show you people how exactly the safe state can change to the unsafe state. Okay, so this was the thing, these were the matrix what were available, what we have considered in the previous example also. The same values I have taken here. Okay, now here what I am assuming that P2 is requesting 1 unit of R2. The allocation of R2 instance to P2 was 0. Now let us imagine that P2 is requesting for 1 instance. Okay, so let me go back here. Yeah, so because P2 is requesting for 1 instance of R2, so I am going to allocate it. So now because 1 instance of R2 has been allocated, the need for P2 is totally 2. So here it will reduce to 1 because it is having 1 instance already allocated. Okay, now because the R2 instance was given, availability of R2 is going to become 0. Okay, so what was the reason? It is because we are going to change the allocation and the need. The maximum required was 2, 1 was given, 1 was needed, total were 2 instances. Now it has reduced to 0. Okay, now again one more change over here. What I will do is, first thing is to check for the availability. Imagine P1 is asking, assume that we are having few more resources of R2 and R3 also. Now P1 requires, P1 requires 2 instance of R1, 1 instance of R2, 0 instance of R3 and 1 instance of R4. Okay, to complete its job. Okay, and P1 is not able to process it because you can see that P1 requires 1 instance of R2 and we don't have any instance of R2 available. So P1 can't be allocated the resources it is asking for. Okay, check with P2. P2 requires 1 instance of R2 and 1 instance of R4. But the availability of R2 is 0 again. So even P2 is not able to acquire the resource R2 because there is no availability. Okay, so once again P2 is also not able to execute. Fine, check with P3. P3 requires 4 instances of R3 but the availability is 1 only. Okay, so because there is in short of resource instances, so all the 3 processes P1, P2 and P3 were not able to acquire the enough of resources what they needed. Okay, hence what happens, the entire system moves to the unsafe state. Now because only allocating this 1 instance to the P2 process will lead to the entire system into the unsafe state. Okay, now any request which is leading the entire state into unsafe state, that means that you are supposed to deny the request. That means we are not able to allocate this 1 to process P2. Okay, so this is the small example of showing that how exactly a small change in the allocation of resources can lead to the unsafe state. I hope you people understood what exactly was the difference between example of safe state as well as the unsafe state. Okay, so this was the explanation about the Banker's algorithm with both the examples where the allocation of resources was leading the entire system into safe state and unsafe state. Hope you people have understood this one. Thank you.